you're looking at an ultraviolet map, and it's all purple, isn't it? Yeah, that's extreme ultraviolet. The increments for low, moderate, high, very high, and extreme, the increments are usually 2 to 3 variables, 2 to 3 integers, 2 to 3 numbers before you go to the next category higher. Once you get to extreme, though, it doesn't go to 13. It seems like there's no cap to it. Now, in the United States, we don't see anything over 14 or 15. But what you're seeing on this map are 16s and 17s. So what does that do to your oceans? It creates really hot oceans, and it creates hot oceanic content, and that creates storms and algae blooms. The reason for all the extra energy, the ultraviolet, extreme ultraviolet, is that there's another object that approached our solar system and probably came into our solar system. It is a failed star, a dead star, a fragment of a brown dwarf. It has altered all the planets and their moons, including our planet and our moon. We have more supermoons because of the increased ellipticality of the moon. With these supermoons come spring tides and king tides, which are rushing in sometimes by a quarter of a mile, and they're blaming it on climate change. But as the oceans warm with all that extreme ultraviolet, they start to release pockets of methane. Methane volume expands, and poof, away they go. They call it devolatilization. This is happening in the permafrost, but it's also happening underneath the water where most people cannot see. And this is, in fact, an X-ray of the Arctic Ocean. And the heat is from an excited solar corona. The sun is brighter. It's so bright that you can now see the moon on the 3rd day of the new moon, where normally you could not. That's because the sun is brighter. And when you look at instruments that measure the energy coming off the sun, they pretty much confirm what I'm telling you, is that many of the energies on the sun have been increasing. Some of them accelerated in their increase or exponential in their increase, like this wavelength, 813 nanometer. 813 nanometer radiation, by the way, is released when lithium loses an electron. So you tell me where the extra lithium's coming from in the corona of the sun. And yes, that would excite the corona of the sun. It would put out more radiation and more light, especially the collisions. So the thermometer, you take the temperature of the sun, it's scorching hot, doesn't relate to how many sunspots there are on the sun whatsoever. There are still some wavelengths that do conform, but most of them are not conforming. And when you look at all the instruments that measure solar radiation, ACRIM, this is the first ACRIM, ACRIM, shows you an increase in solar radiation. So you can't tell me the sun isn't hotter by looking at the proof. Even the reconstructed solar irradiance shows you that irradiance has been increasing, even going into solar minimum, when you would expect it to decrease. Well, that's the radiation coming off the sun. What about the particles coming into the magnetosphere? Those release even higher wavelengths, hotter wavelengths of energy like gamma radiation. This study from March 2015 to June 2017 depicts and chronicles almost a 7 degree per year, 7% rise in the number of cosmic rays, increasing 7% a year. So I wonder what they are today. I did not find a helium stratospheric measurement when I was looking for it. If one of you does have access to an updated stratospheric radiation reading, please link it. This is again 2 instruments measuring the sun plotted on the same graph, and they sure do corroborate one another. That's crazy. And then so our ocean heat content goes up. The way they try to hide it is some people snip off the beginning of the graph and the end of the graph so that the increase doesn't look so steep, that it looks gradual. But that's not the case. The case is that the oceans have rapidly warmed, and when you look at the extreme ultraviolet, you can see why. If the oceans were warm, they would be releasing carbon dioxide, and methane. The top 2 graphs, left and center, carbon dioxide and methane. And look at the rise is exponential. It's accelerated. It resembles some of the other graphs. And along with the ocean heat content, so goes the carbon. You think a carbon tax is going to make that come down? So the ocean's heating up due to this, not carbon dioxide, but to this. This is what heats oceans. It's radiation. And when they talk about the disappearing ice caps, why is that so important? It's because those reflect radiation back into space. Not anymore. So the oxygen is on the lower right, and it is declining. So somebody needs to update that too, because what would deplete our oxygen? That's a model I'd like to see, and I'm wondering if it's the radiation destroying our ozone and fragmenting our oxygen and ionizing our oxygen and creating oxygen isotopes that are no longer O2. I'm wondering if that's what's happening, but not very reassuring. And when we look at global temps, the bluish green line and the sunspots, they're not related anymore, are they? And land-based solar radiance shows the same thing, increasing radiation. And if you think that the sun is increased just a little tiny bit, it hasn't. Its radiation has gone up a lot. But if you were to increase the sun's energy by just a half a watt per meter square, that would equal 37 trillion extra watts of energy. That's in addition to what Earth is already dealing with. And then you look at the ground temperatures, and yes, there's something going on. 15 degrees above average. Are you kidding me? The air 5 degrees above average, 7 degrees above average, 8 degrees above average. The ground 15 degrees? What would heat the ground? Oh, that's right, radiation. So prayers out to Australia. They're not the only ones who's burning. This cloud cover over the capital reminds me of California 2 years ago. Very disturbing to fly over this. You spend an hour over it and you don't see any end in sight. That is apocalyptic. So now you know what I mean by be prepared.
We look out on the city, can't see it today. It's terrible.